Corresponding to assignment 33, as you see, arc length and surface area. This will be example 1, and we'll do all 3 parts, 1, A, B, C. So suppose we have a function. Now, you might notice when we look at these questions that we will give you the function in the form of, sorry, I went to the wrong slide there, in the form of y equals. Just want to remind you that that is interchangeable with f of x. So, you know, it just doesn't matter what notation is used necessarily, but the definition we're about to discuss, you know, they'll put it in functional notation instead of y equals. The other thing would be if they give you an interval from 0 to 2 here, for example, when it says x is between 0 and 2, isn't that just interchangeable with the interval from 0 to 2? So here's our generic picture over here. We have an interval from A to B, 0 to 2 in this specific case, and then we have a continuous function of some kind. As always, we check for continuity first. So we have a graph of a function, a continuous graph from A to B. So that would be our general picture, which would now correspond to our definition. So the idea here is that if you were to graph that continuous function, this again is a general picture, over an interval, we're looking for what's the length of the arc. So the point would be, if you could take that curve and pull it out straight and make it, and then measure that, how long is that piece of string? If you could walk on that curve, how far did you walk? What's the length of that arc? Now, the way you do this is very cookbook. If you look at Roman numeral 1, we find the arc length. Again, if we have a continuous function over a specific interval, so again, this is a continuous function, and this was describing an interval. All right, those are interchangeable. It's very cookbook. There's a lot of theory, obviously, that goes behind this. And here you go. The way you find this, and we're going to use a lowercase s to represent arc length. So you see it here. It's a cookbook. What do? You take the derivative of your function, and then you square it, and then you add 1, and then you put a square root over it, and then you integrate it over your interval. All right? So very cookbook. What we're only going to ask you to do here would be to set up the integral. So, okay. Just like doing the order of operations, let's do the innermost thing first, which is to take the derivative of our function, whatever it happens to be, 6x squared minus 6x. There's your f prime of x. And basically we have everything we need now to set up this particular integral, and it'll be pretty easy, I like to think. So lowercase s for arc length would equal the integral over whatever your interval happens to be, in this case from 0 to 2. This definition has a big square root over it. The theory on it is it comes somewhat from the distance formula that you might recall back in algebra. All right, there's a big proof of where this came from. All right, but basically that would be our f prime of x for this particular function. You put squared on it, plus 1, and then with respect to x. There it is. Now, I'm not asking you to evaluate these. In all honesty, the evaluation of these integrals would require some techniques that you would learn in future calculus classes, Calc 2, whatever it might be. In other words, just show me that you understood how to set it up. So can you follow the cookbook? That's really all it is for this. And really, these I would like to think, be pretty easy questions. I'm not asking you even to go ahead and FOIL that out. You could if you wanted to. You'd have to write that out twice and FOIL it and all that. But, okay, let's just keep it simple. As far as I'm concerned, that takes care of example 1, part A. And frankly, the others are going to be just the same. So I don't know. It's probably overkill to do all of these, but I guess I will. So there you go. That's it for part A. And all we're doing here from one question to the next is we're changing the function and the interval. That doesn't change the recipe whatsoever. So actually, I don't even know what the point is of doing these other two, but I guess I'll do them since we're here enjoying each other's company. Isn't that right, Isaac? Exactly. All right, so 2x cubed minus 21x squared plus 72x minus 79. You'd want to make sure that that's continuous, and it definitely is. There's no division by zero, there's no radicals involved. And again, let's not let it, I did this on purpose, let's not let it concern us that they gave us x as an inequality, a compound inequality. That means the same thing as that interval. So here we go with the cookbook again. If they want the arc length of this particular thing, it's a recipe, you know. F prime of x, we take the derivative of whatever the function is, which in this case is 6x squared minus 42x plus 72. We're making this easy on you. The derivative part of this is not going to be a difficult thing, I would think. And so then this arc length here, but keep in mind, you know, we could change it up here on you a little bit and have you do the quotient rule and things of that type. Negative exponents, whatever would be appropriate. But we integrate over our interval. There's a big old square root here. We take whatever our derivative is. Now the easy thing to forget to do is that the definition for arc length says take that derivative expression and square it. So put it in a big old bracket and put squared. Make sure to add the 1 and then put your dx out there. And that's it. And that would indeed lead to a number. But again, this would be the type of integral that would be extremely difficult for us to do. And so I'm not going to require that part of it. So there will, you know, I'm not even going to put out the possibility of extra credit of going ahead and crunching it out, because actually the integral of this is pretty hard, honestly. Substitution wouldn't even work, for example. So I think we've made our point, but there would be part B, example 1, part B, and let's enjoy one more while we're here. Are you having fun? Gemma, having a good time? Good, all right. So, you get it. The only difference from one example to the next is what is the function. So here we have, now, hey, this would require a rewrite, wouldn't it? Because keep in mind, if you're about to find an arc length, you need to find the derivative of your function. So wouldn't the square root of x to the 7th power become x to the 7/2 power? Right on, all right? So, you know, all those little tricks of the trade we've been using all semester to rewrite the functions. Now we find the derivative. Okay, so f prime of x. Oh, this is just power rule, isn't it? So 7/2 times 4. Why am I blitzing out? That's 28/2, that's 14. 7/2 times 4, that's just arithmetic. I hope I did my arithmetic right. 28 over 4, 28 over 2, pardon me. 14x 7/2 minus 1 would be 5/2. All right, so there you got that. Lowercase s for arc length. There's a capital S that we'll talk about later that represents something else. So let's make sure that's a lowercase s. And we integrate from 3 to 7. We don't have to find the interval. It's already given to us in the question. And here we go, big old honkin' square root. 14x to the 5/2 power. I'll make it resemble this. In brackets, it could be parentheses, squared plus 1 and dx. And we just have to tell you that really smart math people figured out this thing. And so, you know, let's go for it. You wouldn't have to, but I would point out on this one, it has different structure than the others. If you're going to square a quantity that's comprised of only multiplication, and you don't have to simplify this, even though I should probably have you do so. But, you know, in this case, the algebra, as far as squaring that quantity, would be easy because of the multiplication. We can just drop it in there. And so 14 squared, I think, is 196. Is it 196? Is that what you got, Shelby? Yeah, okay. 196. X, power on top of power, you multiply them. That would be to the 5th plus 1. That would get you one step closer to actually calculating that integral. I will again tell you, though, that integrating that particular function is beyond the skills we have. So, Calc 1, a lot of times you learn how to set up things, and then when you take more calculus, Calc 2, and so on, then you learn how to integrate those more difficult types of integrals. So that's basically example number 1, parts A, B, C, and now we'll transition from there and talk about a similar related idea. All right, so we'll be right back.